This is the 2009 AP Equilibrium problem, and it's based around the weak-base ethylamine. So be sure to watch out for this. So these things like ammonia and then NH2 groups on the end of an alkane are all going to act as bases. They're all going to pick up hydrogen from water and form a hydroxide. Okay, so this one starts out and just asks you to find the concentration of ethylamine. So you have 14.85 grams, and you want to change that to moles. So if you add that up, you're going to get 45.09, that's grams per mole. And that will give you 0.3293 moles. Okay, so then what do? You take that 0.3293 moles and divide it by the number of liters. So 500 milliliters is half a liter, and when you do, you're going to get 0.659 molar. Alright, so the first part was fairly easy, and that is worth 2 points. You get a point for the number of moles and a point for the concentration. So the next part of the question asks you just to write the equilibrium expression. So because it's a base, we want to use Kb, and Kb is going to be equal to, so you want the concentration of the products, C2H5NH3 plus and OH minus, and that's going to be over C2H5NH2. So that's the ethylamine. And notice that we are not going to include water. So that's another point. Okay, in this part you just have a question, no calculation. You just have to answer the question and explain your answer. So the question is, which is going to be present in higher concentration? So we know this is a weak base. So what does it mean to be a weak base? It means that you just get a small amount of ions formed over here. So the question about which is going to be present at higher concentration, it's going to be this one. The reason is because this is a weak base, and weak bases only ionize to a small extent. In this question, you're asked to find the OH concentration, and it's a little misleading because they give you, at the top up here, they give you some information, and you might be tempted to use that for something, but not yet. They're going to lead you through sort of step by step. So the first question is to find the pH, or to find the OH concentration when the pH is 10.93. Okay, so you can go about it this way. There are a couple of ways to do it, but you can say that pOH is equal to 14 minus 10.93. So that means that the pOH is equal to 3.07. And what do we do here? Well, we say that the OH concentration is going to be equal to 10 to the minus pOH, and that means 10 to the minus 3.07. It's an equal sign, and that means that the OH concentration will be equal to 8.5 times 10 to the minus fourth. Alright, so that's a point. Alright, so you want to write the reaction between the weak base, which is C2H5NH2, and for a strong acid, we'll just write H+. Again, not equilibrium. This is just a reaction because it's strong with something weak. So over here, you're just going to get C2H5NH 3 plus. Okay, for this section you have to calculate, first of all, how many moles of the C2H5NH2 and the strong acid you have. So you're told that you have got a volume of 0.5 liters, and you're also told that the concentration is 0.5 molar. So that's going to give you 0.25 moles. And for the HCl, you're told also that you have another 0.5 liters, and the concentration is 0.2 molar. So that's going to give you 0.1 moles. Alright, so you can start with 0. This one's going to go down by 0.1. This one's going to go down by 0.1. This one's going to go up by 0.1. So after the reaction takes place, this one will be 0.1, this one will be 0, and this one will be 0.15. Okay, so you want the concentration over here of the C2H5NH3+. So you've got 0.1 moles, and up here you added half a liter and another half a liter, so that makes a liter. So that's basically just 1 liter. So that means your concentration is 0.1 molar. Okay, so take a look at all this because we'll be using some of this information in the next part of the problem. Alright, this is the last step. So this one is asking to calculate Kb for the reaction that we had with the, I think, the second step. So that's going to be, you want the concentration of C2H5NH3 plus and concentration of OH. So this is just products over reactants. And then that's over concentration C2H5NH2. Okay, so look at what we have. This we had from earlier in the problem, so that goes there. This one we just calculated. This one will go here. And then this, if you look back at the previous part of the problem, was what we had, the number of moles that we had earlier in this last step. Okay, so when you put all those in, you get Kb equals 5.67 times 10 to the minus fourth. So you actually had calculated everything that you needed for this problem previously, and that's very typical of AP problems, is that at the end you'll use the information that you have calculated previously.